All right, today we're going to do integrals for bases other than e. And again, we just have to keep remembering that integration is the opposite process of differentiation. And so it's really the same thing, we're just going backwards now. And so here we have the integral of base a to the u power with respect to u. And this is pretty familiar to us now. So we have 1 over natural log of a, and it's going to be times a to the u and plus c. So notice when you're doing integration, the du happens in the integral, right? We don't deal with it outside.
No chain rule.
Okay? No chain rule. We just got to deal with that inside. So as we're looking at this, the integral of 2 to the x power with respect to x, so a in this case, our base, is 2, and u is just the function x, and du equals 1 dx.
Mr. Paul,
Mm-hmm.
I had someone tell me that with antiderivatives, whenever you see a non-x for your exponent, you have to use substitution. Is that true?
Whenever you see a non-x,
Yeah, if it's just pure x, you don't have to use substitution. But if it's like an x squared or a negative x, you have to use substitution.
right. So if the function is just x, you don't have to use u because the derivative of x is 1.
Yeah.
So that's why you don't have to deal with it. Okay? I just do it so that you can see all the parts in relation to the actual formula. Okay? So, in this case, we have 2 to the u du, and so this is just going to be 1 over natural log of 2 times 2 to the x power, and we have our plus c because we have our family of integrals that are going to work there, and then we'll just rewrite this as a single fraction. And there it is. Okay, for letter B here, our base is 4, our u is negative x, and du is negative 1 dx. So I don't see negative 1 dx here, so we have to add that in. And if we put that factor on the inside, we're going to put it on the outside as well. Okay. So those cancel each other out right there. Okay, so all in all, we're just going to carry down that negative. And then we're going to perform the integration. So 1 over natural log of the base, 4, times 4 to the negative x, and then plus c. Okay, and if we don't want to write negative x, how else can we write that?
4 over x.
Yeah.
So can we do 4 over x and 1 forward?
So we would do 1 over natural log of 4 times 4 to the x. Something like that. You could leave it 4 to the negative x also. It doesn't matter. Okay, in our next one, here we have the integral of x times 6 to the negative x squared with respect to x. Okay, so looking at this, what is our base? 6. So a is 6. And what do we want to let u equal?
Negative x squared.
Negative x squared. So du,
Negative 2x.
negative 2x dx. Okay, so what factor are we missing in the integral?
Negative 3.
Negative 3, what?
Negative 1/2.
Here I see x dx. We need negative 2x dx.
Here's your bottom.
What's up?
So from here, like what I've been doing is solving for the dx. You bring the 2x over to this du over negative 2x.
Mm-hmm.
So you substitute du over negative 2x for your dx.
Mm-hmm.
The x's cancel out, and then you pull out negative 1/2 from the same spot that you are.
Mm-hmm. Yeah. Same place. Okay, so we need the negative 1/2. And we have negative 2x times 6 to the negative x squared dx. And so here is the du. And there's our u. Okay. So we'll just put this negative 1/2 out here in front. And if we were to write this, we could just say 6 to the u d, just so you can see it there. But our final answer then, negative 1/2 times 1 over natural log of 6 times 6 to the negative x squared plus c. Okay, and we can just write it now as 1 fraction so we'd have negative 6 to the negative x squared over 2 ln 6 plus c.
Shouldn't we bring that 6 to the negative x squared down?
You can. Or you can just leave it there.
You should do that for the
If you brought it down, where would it go?
just after.
It would just go after.
Okay.
Becomes
So
6
you
to the
couldn't
x
do
squared.
like 12
No.
x squared?
No, because the
Exponents are different.
exponents are different. Okay, so that's integrals for bases other than e. So pretty simple process, kind of the same thing that we've been doing. Okay, now we're going to look at 4 forms of exponential differentiation. So these are all different types of problems.
But there's 5.
There's 5 problems, but there are 4 forms we're going to look at. Yeah.
That's confusing.
That's the point. So we have multiple forms, but many problems. Which form are we looking at? Okay, so looking at this first one, if we have y equals e to the e, and we want to find y prime for all of these. Okay, e to the e is just a constant. So this is just using the constant rule here. So y prime equals 0. Okay. Our next one, y equals e to the x. So here you have a base e, the exponent is x. This is the exponential rule. So y prime will just be e to the x. dx, but it's just 1.
Just the element of e is 1.
For our next one, y equals x to the e. So we just switch the base and the exponent here, and all of a sudden this becomes a power rule. Okay, so we're raising x to the power of e. So y prime is going to be e x e e minus 1.
Is the E just the D of E?
E's a number.
Yeah, e's a number.
Or is something? Is that the derivative of E?
No, we're just using the normal power rule here. So think of something like,
Oh, you just pulled it out in front and then divide, subtract it around.
yeah, you pull it out in
Okay.
front and then subtract 1. Okay. And then, so those are three problems involving exponents that we do in 3 different ways. Now letter D right here, y equals x to the x power. So there is no e. There's no constant either. So when you're confronted with something like this, you want to bring in the natural log. So here we're going to use logarithmic differentiation. Because it's going to help us deal with those exponents. Okay, and we've done this a little bit before. So we're going to take the natural log of both sides. Okay. And then we can rewrite this. So this is really x ln of x. Okay, now we're going to take the derivative of both sides.
X on that x to the log of the third.
Mm-hmm. Take the derivative of both sides there. So derivative of natural log of y is just going to be y prime over y. And then we have a little bit of a product rule here. So x times the derivative of natural log, which is 1 over x. And then derivative of x is 1 times natural log of x. Yeah, we're going to multiply by 1. Let's clean it up a little bit here. So that's just 1 plus natural log of x. Now we are going to multiply both sides by y. And notice we do that because we're looking for y prime. That's our ultimate goal. So y is x to the x. Okay, and then you're done.
Hooray.
Hooray! Okay, so when you're dealing with exponents that you really can't do anything with the way they are, you're going to use logarithmic differentiation. Okay.
Is there more notes after this? This is it.
So for letter E, Sure.
No, just, I was confused, it was y to x to the x, that's because y equals that.
Yes. Okay, so in our next example, also, we don't have any e's anywhere, so we are going to use logarithmic differentiation.
You need to have Swedish mouse today. Really like them.
Oh, I missed one up here on the power. There we go. Get it in there. Yay. Okay. Before we take the derivative, let's go ahead and rewrite this. Do you want to use product rule or quotient rule? Product rule. Okay.
So it's 2x to the negative 1.
That's 2x to the negative 1. Alright, and so the negative then comes in front. Then we decrease it to x to the negative 2. So we really have negative 2 over x squared. And then the derivative of ln of x, 1 over x.
They're both x squares.
They're both x squared. That is nice. So looking at combining this up here, can we write 2 minus 2 ln x? Is that okay?
Yeah.
So I just put the positive 2 first. Yeah, just times by y now. Which is x to the 2x. So x to the 2 over x.
Then you're done?
We could be done.
Or not.
When-
Further simplify that x.
Because of these like bases right here. Okay. Yeah, so if you divide two exponents with like bases, you subtract the exponent.
So you just end up.
So you could really do x to the 2 over x minus 2 times 2 minus 2 ln x.
If you're dividing exponents,
Mm-hmm.
they're the same base.
Yes.
Wait, can you move it down a little bit?
Sure. Alright, so if you did like x over a divided by x to the b,
Wait.
How do you do that? Because the top is together by a subtraction sign. So you have,
well, this would just multiply and then it'd be a factor of it. So because it's a factor, you can do
Oh,
this.
yeah, I see. It's,
And I guess we could even factor out a 2 if you wanted to.
So that just got rid of the entire bottom?
Mm-hmm.
It almost doesn't seem real that something that simple would be so complicated.
It does get kind of complicated.
So just do an x cubed to the power of x cubed.
graph of x, that's the
You just said x cubed to the power of x cubed.
It's x squared.
All right. Any questions there?
What if the bottom was bigger? Like, what if it was, like, you know, you use subtract, right?
Even if the bottom is bigger, you can still subtract here.
You just subtract whatever.
Yeah.
They have the, like, bases.
Because let's say if this was like 3, or if this was 1, and that was 2, you would do 1 minus 2, which is negative 1.
Would you leave it saying 1 minus 2, or would you combine them?
You could combine them if
But in this case, you can't because they're not like.
because of the variable. Yep.
It's exponentially exponential.
All right. So that is it for today. You guys will have time to work on your assignment.